Seismic survey is an important and in many cases the most accurate, though the most expensive and time-consuming, method of geophysical prospecting. It is used to solve various geological problems, such as the study of the physical and mechanical properties of rocks, or the crust and upper mantle at the depth of several dozens or even hundreds of kilometers. However, its main purpose is oil and gas prospecting and exploration. At present, over 3/4 of geophysical surveys in Russia are seismic ones. TNG Group is one of the leaders in the field of seismic survey. Experience of works performed in the most difficult climatic and geological conditions, a staff of highly qualified professionals, and the most up-to-date equipment from the best world manufacturers ensure a high level of fieldworks organization. In addition, the company pays the utmost attention to meeting the highest occupational health and safety standards. Today, TNG Group owns the whole range of technologies and technical means capable of improving the efficiency of geological exploration works. One of the most advanced technologies offered by TNG Group to the customers is RT System Wireless Seismic. It is hardly an exaggeration to say that it is the cableless surveillance systems that are recognized in the world as the most promising. Having proved successful abroad, they are beginning to be applied in Russia. Their main advantage is the reduction of time spent on exploring the area and increasing productivity, which is particularly important for our country, where the geological survey season is limited. The seismic survey begins with topographic and geodetic works. Global positioning systems, electronic tachometers, and modern software allow to provide meter and, if required, centimeter surveying accuracy of geophysical measurements points. The sources of seismic vibrations are selected depending on the geological conditions of the prospected area. Most projects use the explosion seismic method. The drilled wells are filled with explosives, the detonation of which causes seismic waves that are reflected from the boundaries between the layers of terrestrial rocks. In cases where drilling is difficult and the use of explosive charges is inadvisable, for example, whether in the tundra, steppes or sandy deserts, the seismic vibrators are used. In areas where drilling is inadvisable due to the presence of solid formations, the non-explosive pulse sources are applied. Wireless field units are placed along the prepared geophysical lines. The cable-free system significantly optimizes the production cycle due to the rapid placements of sensors in the conditions of rough terrain. Moreover, the time spent on equipment placement is reduced to 20%, which is especially important when it comes to large-scale projects and the use of more than a dozen channels. The self-organizing system architecture corresponds to the connectivity of cable systems, but at the same time excludes topology and data readout errors. The unit performs self-diagnostics and confirms its readiness for operation 35 to 45 seconds after installation. After creating artificial seismic waves, whether they are resulting from explosions, pulse or seismic vibration sources, each wireless field unit digitizes signals from external analog geophones and transmits data along with those from other units over the WRU line until they reach the LIU. The data are then converted into Ethernet packets, which are transmitted to the central seismic data recording station via a high-speed broadcast network. Unlike most cable-free systems that work offline and therefore do not allow to evaluate the quality of each individual seismogram online, the system used by TNG Group is the only one to date that enables real-time data acquisition. They are delivered to the station immediately in the generally accepted SEG-Y seismogram format. The seismic station operator can quickly check the system state and data quality, so-called live check, by recording and, if required, immediately eliminating unexpected extraneous interferences, degrading the quality of the data. The system works steadily at low temperatures typical for the northern regions. Next-generation batteries can maintain continuous 24/7 recording from 12 to 20 days and require from 8 to 12 hours for charging. Thus, TNG Group uses not only the benefits of the standard cable system, but also the additional advantages of the cableless one that provides real-time data acquisition and accelerated deployment in locations that are not easily accessible, thereby greatly simplifying the conduct of seismic works in difficult areas, agricultural fields, wetlands, environmentally sensitive areas, as well as areas near facilities of industrial or residential infrastructure. The cableless surveillance system allows to reduce the volume of felled timber, which is especially important when working in the impassable Siberian taiga. Moreover, the reduction of the anthropogenic impact on nature is not the only advantage. This technology also helps to increase the level of industrial safety, since the main risks of injury during seismic survey are associated with tree felling operations. Efficiency, safety, and environmental friendliness are the main criteria met by the cableless data recording system technology, which is merely one of the advanced developments used in TNG Groups. We are doing our best by continuously improving the production process to ensure that the economic return on the customer's investments in geological exploration is maximum.